Hello students, hope you are doing well. In this video, we are going to discuss case study how SDN changed traditional enterprise network design of Unit 6 software defined network for the subject enterprise network design of B7 semester IT University of Mumbai. Now there is a question, what are the benefits of software defined network SDN and how it is different from traditional networking? So, when it comes to creating their own network, every enterprise has to weigh the pros and cons of the different network types. With increased consumer demands for performance and flexibility, some cons quickly become heavier than others. Along with the growing needs of modern networks, the biggest cons of maintaining traditional network have encouraged the dominance of SDN. SDN solution and other virtualized solutions are growing. Globe Newswire argues that the SDN market will reach US $59 billion by 2023. Physical infrastructure, especially hardware that require manual configurations, simply has not been able to keep pace with modern technology. The ballooning demand that modern enterprise users require are too much for most traditional networks. Users looking to upscale their network infrastructure with as little disruption as possible quickly turn to SDN. So, what is SDN? Already discussed in previous slides also. So, let us define SDN. SDN is defined by the decoupling of control and packet forwarding plane in the network. Control and packet forwarding plane. Okay. It enables network to directly connect to applications through application programming interface, bolstering application performance and security, and creating a flexible dynamic network architecture that can be changed as needed. Arguably, the most frequently used means for application deployment, SDN is used by enterprises to deploy their application faster while also cutting the overall deployment and operating costs. IT administrators using SDN can manage and provision their network service from centralized point. A network paradigm that produces programmatic management and control and network resource optimization. SDN applies open APIs to help maintain network control. This network control is created when SDN decouples the network configurations and traffic engineering, separating them from their fundamental hardware infrastructure. This parting allows the use of OpenFlow and other open protocols. These open protocol can access network switches and routers that often use proprietary and otherwise closed firmware by applying globally aware software control at the network's edge. So the control plane and data plane and early SDN implementation, what is this? SDN helps users virtualize their hardware and works to create a computer network by breaking down the network into separate planes. First is control plane. It offers the performance and fault management of NetFlow and other similar protocol. It is frequently used for managing devices configuration that are remotely connected to a software-defined network. The data plane forwards traffic to its desired destination before traffic reaches the data plane. The control plane dictates what path flow it will take by using the flow protocol when a network administrator works with the software defined network and manages the network. Now, this is how it is work with the software defined network. Okay. And now come to when it was, you know, When flexibility is recurring hurdle for traditional network, few APIs are exposed for provisioning and most switching hardware and software is proprietary. Traditional network often work well with proprietary provisioning software, but this software cannot be quickly modified as needed. Traditional networking consists of different threads. So first is the functional. The main traits is the function of traditional networking are primarily implemented from dedicated devices using one or more switch as well as routers and application delivery controls. Traditional networking. This is primarily implemented from dedicated devices like router. You have routers in your home as well as switches, application delivery controls, etc. The functionality, second thing is the functionality of traditional networking is largely implemented in dedicated hardware, such as application specific integrated circuit. These are also known as ASIC, already discussed in previous chapter. One of the negative aspect of this traditional hardware centric networking is its limitation because it is already predefined. How do we change this? So we need a framework which is open to all. Now come to what are the differences between SDN and traditional networking. This is very important thing. The most notable difference between SDN and traditional networking is that SDN is software based while traditional networking is usually hardware based. Unlike, not unlike, like in previous computers also, the first generation computer is purely hardware based and it is hardware kind of thing. And after the concept of Moore's machine gives you a concept that you can change the programming steps and it will automatically change the outputs also. So likewise, nowadays, networking is also based on such concept. You can change the configuration of device, you can change the firmware of device, and you can do anything with the device. Devices are very, very flexible because it is software based. SDN is more flexible, allowing user greater control and ease of managing resources virtually throughout the control plane. Inversely, traditional networks use switches, routers, and other physical infrastructure to create connections and run the network. SDN controllers features northbound interface that communicates with APIs. Because of this communication, application developers can directly program the network as opposed to using the protocols required by the traditional networking. SDN lets users use software to provision new devices instead of using physical infrastructure. So IoT administrator can direct network paths and proactively arrange network services. Unlike traditional switches, SDN also has the ability to better communicate with devices using the network virtualization. Epitomize it actually epitomizes the primary difference between SDN and traditional network. When SDN virtualizes your entire network, it generates an abstract copy of your physical network and lets your provision network from centralized location. Opposingly, with a traditional network, the physical location of the control plane hinders an IT administrator's ability to control the traffic flow. With SDN, the control plane becomes software based, allowing it to be accessed through a connected device. This access lets IT administrators manage traffic flow with greater detail from a centralized user interface. This centralized location grants user greater control over how their network works and how their networks are configured. The ability to quickly process different network configuration from a centralized user interface is especially beneficial for network segmentation. SDN becomes a popular alternative to traditional networking because It lets IT administrator provision resources and bandwidth as needed without requiring an investment of additional physical infrastructure. Traditional networking requires new hardware to increase its network capacity. The paradigm for SDN versus traditional networking could be distilled to generalization. One require more equipment for expansion and other require only keystrokes. So, what are the primary advantages of SDN? These advantages include traffic programmability, greater agility, capacity to generate policy-driven network supervision, ability to implement network automation. So, SDN has the advantage of generating a framework that bolsters data-intensive applications such as big data and virtualization. Big data and virtual machines are somewhat intertwined. Ingram Micro argues that virtualization adoption is being driven by big data, and SDN provides a means to manage virtual machines and big data network traffic. In addition to centralizing and simplifying the control of enterprise network management, SDN offers these advantages, which already discussed: traffic programmability, greater agility, capacity to generate policy driven network supervision, and ability to implement network automation. Okay, there are several of the primary advantages of SDN offers. First advantage includes centralized network provisioning. What does it mean? SDN helps centralize enterprise management and provisioning by offering unified perspective on the whole network. SDN can also speed up service delivery and boosted agility in provisioning virtual and physical network devices in the central location. Second is holistic enterprise network management. Networks must meet the rising demand for processing requests, as in helps your IT department adjust your network configuration with no impact on your network. Also, unlike simple network management protocol, SNMP, this SDN bolsters the management of physical and virtual switches and network devices that are from the central controller. Third is more granular security. Virtual machines poses a challenge for firewalls and content filtering, a challenge that is further compounded by personal device. By establishing a central control point for regulating security and policy information for your enterprise. The SDN controller quickly becomes a boon for your IT department. Lower operating costs is the fourth point. Several benefits of SDN, such as having an efficient administration, server utilization improvements, and improved virtualization control, can dually help cut operating costs. Because many regular network administration issues can be automated and centralized, SDN can also help reduce operating costs and grow administrative savings. Fifth advantage is hardware savings and reduce capital expenditures. SDN adoption helps revive older network devices and simplifies the process of optimizing commoditized hardware. By following the infrastructure from the SDN controller, older hardware can be repurposed while less costly hardware can be deployed to optimal effect. This process allows new devices to become veritable white box switches that have intelligence focus at SDN controller. The sixth advantage, cloud abstraction. Using SDN to abstract cloud services helps simplify and process of unifying cloud resources. SDN controller can manage all the networking components that comprise the massive data center platforms. And last, consistent and timely content delivery. One big benefit of SDN is that the ability to manipulate data traffic. It is easier to have quality of service for voice over internet protocol and multimedia transmission if you can direct and automate data traffic. SDN also helps with streaming higher quality videos since SDN bolsters network responsiveness and therefore creates an improved user experience. UX, you can say in your own language. Why are companies transitioning to SDN from traditional network? In addition to its many benefits, here are several other reasons why data enterprise are opting for SDN over traditional network. Number one is today's users demand a what kind untethered access to infrastructure, application, and IT resources. This demand comes as a result of proliferation of cloud service, which necessitates additional storage, computing, and bandwidth. The second advantage is the advent of bring your own device in workplace. Yes or no? It requires dynamic and flexible network. These networks must also be security rich and capable of protecting data and assets and meeting compliance regulations and standards because it adheres to protect to product cycles and vendor specific environment proprietary interfaces. Traditional networking is unable to meet these demands. Traditional networking tends to be rigid, making it difficult for network operators and administrators to customize the programming of their network. The process of adding devices or increasing network capacity is cumbersome and time consuming. So, necessitating hands on access for each console and device. Okay. Third advantage may be SDN lets network operators and administrators adjust their resources and bandwidths as needed, providing data centers with boosted efficiency, malleability, and resiliency. Also, SDN doesn't require investing in physical infrastructure and isn't largely capable of being automated, which further bolsters the chances of enterprises to cut cost and improve network performance. So next is SDN infrastructure versus traditional network infrastructure. In this case, the rise of cloud computing and increased demand for mobility and remote collaboration is putting more pressure on traditional enterprise network to perform like cloud networks. Yes or no? For enterprises with these traditional networks, the situation often result in slower innovation. That is the important point. Development and production. In the IBM white paper, Software Defined Networking in the New Business Frontier, the author argues that traditional network architecture that are too old, rigid, and expensive to scale are out of alignment with today's hybrid cloud. A combination of traditional public and private cloud infrastructure and IT as a service deployment. Networks that are automated and optimized within virtualized and hybrid IT environment are more likely to help enterprises produce greater innovations and reduction in cost and complexity. For traditional network infrastructure, each switch determines where traffic goes and then directs the traffic based off of these determinations. With SDN infrastructure, the process of determination and direction has been decoupled. Switches still direct the traffic, however, the process of determining where the traffic goes is performed by an automated programmable interface. It is also known as an SDN controller. This centralized control point automates network management and control and has oversight into all of the SDN nodes. Performed from a centralized control point that integrates the information and waves the network switches together into a single unified platform. This platform allows network administrator to change network-wide setting with a centralized console, whereas traditional network infrastructure might warrant deploying network changes in a piecemeal fashion for individual devices. The centralized console of SDN's infrastructure helped streamline the process of performing network changes. With a centralized console, the software is able to deploy necessary network changes cohesively and uniformly to all necessary devices. Multi-vendor switching equipment can also deploy any necessary changes using a single interface. The IBM white paper states that this white paper is on as SDN answers. It states that the need for agility, scalability, and visibility by transforming hardware-intensive legacy network into fully programmable virtualized SDN that streamline operations and delivery of new services. Fourth point is SDN infrastructure gives network administrators the flexibility to change network traffic and enables network resource deployment that scales at the same speed as server and storage, redirecting it as needed. Additionally, the SDN controller reduces complexity and enables the network to scale as needed. The benefit of SDN are that it can help enterprises promote innovations and deployment and accelerate time to time market for applications and services. So with this, we finishes this case study. So this is the last lecture of this subject, software-defined network. So I hope that each and everything is very clear and you will definitely secure the good marks. And the subject is bit theoretical, but it is expected from all the users that they maintain, they draw a lot of diagram and explain with the help of diagram. Okay. So with this, I wish you all the best. Have a nice day. Have a nice time. Thank you very much. Bye bye. Take care. Good luck for your examinations.